Have you ever wondered about the enigmatic objects in the universe that swallow everything in their path, leaving behind nothing but a void? These mysterious entities are known as black holes. But what exactly are black holes, and how do they form? Let's delve into the world of black holes and explore the many questions that surround them. Believe it or not, only questions can manage to survive around them. Because as soon as they try getting closer to find an answer, they are swallowed by ever mysterious black holes. Not too long ago, the existence of black holes was nothing more than a speculative notion. Rewind a few centuries, and the understanding of gravity was still in its infancy. Sir Isaac Newton's groundbreaking work in the 18th century gave us the concept of gravity. However, the concept of gravity was much more complex than the one proposed by Newton's law of gravity. In 1915, Albert Einstein's theory of general relativity proposed that space and time are interconnected. The placement of matter bends the graph. That's what we call gravity. In return, the droopy space-time outlines the movement of matter around those masses. It even proposed that neither space is the same for everyone, nor time ticks at a constant speed. Amidst all this chaos, the tantalizing question emerged. Could there be an entity that can bend the space-time graph to infinity? To be more precise, could there be a black hole? The saga of discovering black holes unfolds over decades, involving some of the brightest minds in the scientific community. In the 1930s, physicist Robert Oppenheimer proposed the idea that massive stars might collapse under their own gravity, giving birth to objects with such potent gravity that escape became impossible. However, it wasn't until the 1960s that astronomers started amassing evidence for the existence of these cosmic enigmas. One crucial piece of the puzzle emerged from observations of X-ray emissions emanating from space. These emissions, entirely distinct from anything seen before, hinted at the presence of intensely dense objects wielding powerful gravitational forces. In 1964, astronomers John Wheeler and Kip Thorne officially labeled these mysterious entities as black holes. The 1970s marked the era when direct evidence for black holes finally came into view. In 1971, astronomers stumbled upon a star orbiting an unseen entity in the Cygnus constellation. This concealed object surpassed the mass of a typical star, exerting a gravitational pull far too mighty for its size. This revelation served as compelling proof of the existence of a black hole. Since then, our cosmic detective work has led us to discover numerous black holes scattered throughout the universe. Now, let's break down the cosmic mechanics behind the formation of a black hole. Picture a colossal star, hundreds of times more massive than our Sun, reaching the end of its stellar journey. Under its own overwhelming gravity, it collapses into a mind-bogglingly small space just 60 kilometers across. That's like squeezing all that mass into a space barely larger than a mid-sized city. The result: infinite density in an infinitesimal space. If you want to know more about the formation of black holes, don't forget to check out the link in the top right corner. But what makes a black hole so different from other celestial objects? The answer lies in its gravity. This newly formed black hole is a gravitational powerhouse ready to devour anything in its vicinity. This phenomenon is known as spaghettification, and it's what happens to objects that come too close to a black hole. Imagine you're an unsuspecting astronaut approaching a black hole. As you get nearer, the black hole's gravitational pull becomes a relentless force. But here's the twist. It's not a gentle tug. It's an interstellar game of tug-of-war gone wild. The gravity at play is so intense that it starts stretching you out like a piece of spaghetti. No kidding. Your once cohesive self gets elongated into a long, thin strand until, well, you're torn apart. It's like getting pulled into a black hole pasta maker. A little gruesome, a lot mind-bending. Now, here's where it gets even more mind-boggling. Anything unlucky enough to be caught in this gravitational pull doesn't just get shredded straight ahead. The whole spaghettification begins when you start swirling around the black hole at an insane speed. Think spinning at about half the speed of light. You might want to resist and get out of the whole chaos. But believe it or not, you won't be able to escape it. Now, you might be wondering, if nothing can escape a black hole, how on earth do we observe it? Well, here's the catch: while peering into the heart of a black hole is a no-go due to its intense gravity, we're not entirely in the dark. We can see what's happening inside the black hole, but we can still observe those celestial bodies orbiting around it. By keenly observing the intricate orbits of stars in the vicinity, we can deduce the black hole's mass and its cosmic whereabouts. But that's not all. Another tool in our cosmic toolkit is gravitational lensing. As light traverses the space near a black hole, the immense gravitational field warps its trajectory. This bending of light, known as gravitational lensing, acts as a celestial magnifying glass, offering a sneak peek into the black hole's size and shape. It's like studying shadows cast by an unseen object, revealing the contours of the hidden cosmic landscape. Now, let's dive into the intriguing territory around the black hole. Imagine this invisible boundary called the event horizon. It's like the cosmic point of no return. Once you're past it, there's no turning back, not even for light. It's the line between the seen and the unseen. It signals the start of a journey into the vast groove of space and time where the universe takes an unexpected turn. Venturing into the heart of a black hole is like stepping into the unknown. Our current understanding of physics hits a roadblock as we encounter the mind-bending mysteries within. Once you breach the event horizon and venture toward the center, things get downright confusing. Black holes are like a being of the universe that have superseded everything we know about the cosmos. There are, however, multiple theories of what would happen to a person when they fall inside a black hole. Would they be led onto a different dimension entirely, where the laws of physics would be totally different? Some even speculate a speck of the divine inside, and reinforce the idea of complexities beyond human comprehension. Black holes might just be the one thing we cannot find the answer to. So if you want to know what's inside it, you might as well just try jumping in. Being in the vicinity of a black hole is like playing with cosmic fire. Its gravitational pull is so fierce that once you're in its grip, escape becomes a near impossible feat. But here's where things get interesting. Theoretical models propose a cosmic loophole in the form of Hawking radiation. Named after physicist Stephen Hawking, this concept introduces a twist in our understanding of black holes. Ever wondered how a black hole, known for its insatiable appetite, might actually lose weight? According to quantum mechanics, nothingness in the universe can give rise to a pair of particles and antiparticles. What if such a pair happens to form around a black hole where time seems to stop? Its gravitational pull may consume one particle while setting the other free. It's a subtle yet profound process, causing black holes to shed mass over time. At first, the idea that black holes can change over time is exciting, but we need to remember how long they actually live. A black hole as big as our sun would survive for trillions of years. That's a really long time. In fact, even the tiniest fraction of a black hole's lifetime is longer than the entire history of our known universe. It's hard to comprehend these enormous timescales, but they're a reminder of how patient we need to be when trying to understand the vastness of the universe. What's your take on the mind-bending world of black holes? Share your thoughts in the comments below. For more captivating journeys through the universe, hit that subscribe button and ring the notification bell. Until our next cosmic exploration, keep pondering the mysteries of the cosmos. See you on the flip side, space enthusiasts. This is Mars 666 signing off.